Uh, Thank you so much, Stephen, for taking out the time and joining us all the way from Serbia. This is a great honor for you having you here. Now, for our fourth speaker. Our fourth speaker is the name of our fourth speaker is Dr. Tariq Umar. Tariq Umar has completed his PhD degree in construction management from London South Bank University and registered as a chartered civil engineer at the International Professional Engineering with Engineering Council UK. He has more than 18 years of international experience involving different positions in industry and academia. He is an approved mentor of the Institution of Civil Engineers and helping graduates to become professional qualified engineers. He's also serving as a member of the editorial board, advisor, reviewer of several journals. His research interests include, but not limited to, construction management, safety and health, engineering, sustainability, construction materials, renewable energy, waste and resource management, and construction 4.0. Tariq is also a fellow of Advanced HE. Today, he will talk about emission from municipal solid waste and its potential for energy production. Without further ado, I would like to invite Dr. Tariq Umar for his talk.
Thank you very much, Dr. Hussain. I just want to share my presentation. So give me a minute, right? Could you please confirm that my voice is clear and loud?
It is clear and we can see your screen as well.
All right. Well, thank you very much for inviting me to be a guest speaker in your prestige conference. Um, my name is Dr. Tariq Umar, and I'm a lecturer in construction project management at the University of the West of England. And my talk is covering the emission from municipal solid waste management and its potential for energy production. So let me give you a brief outline of my presentation. So first of all, I will try to introduce my topic itself, and then I will cover the emission from municipal solid waste. And when I will be covering the emission from municipal solid waste, so we have created a number of frameworks considering different scenario and try to compare their emission from different scenario. So I will be covering those proposed framework and how it's compared with each other. And then I will also try to cover that how we can produce energy from that municipal solid waste, considering the specific example of Oman. When I will cover the waste to energy plant, so of course there are other factors when we used municipal solid waste in a waste to energy plant that of course also produce emission. So apart from emission, I will also cover cost related factor as well. And then at the end, there will be a summary and concluding remark. Because my research was based in Oman, so you can see here, this is a typical type of landfill, which basically where the municipal solid waste is basically disposed of. So let's look at to the introduction. So as I mentioned that my research is going to present the research work which I have conducted in Oman on municipal solid waste management. So Oman is one of the countries, of course, most of you will know, of the GCC region, which includes Saudi Arabia, Oman itself, United Arab Emirates, Kuwait, and Qatar. Here is just a brief map of Oman. So if you try to compare, Saudi Arabia is a bigger country in the region. Oman is not that bigger, but if you compare with UAE, Qatar, and Kuwait, of course, that is occupying or having a big area compared to these countries. These are rich countries. The reason is that because they have very good reserve of oil and gas, and because of that, they are selling that reserve to the countries in the form of oil and gas. They are rich countries, and thus they are a main consumer of the earth resources. So you can say uh, the energy resources, they are the main consumer. You can compare to other resources. Um, uh, so when they are main consumer, so their production or their generation of municipal solid waste is also very high when we compare with other countries, which I will cover in a bit. Um, just try to give you a global scenario. So municipal solid waste is basically not a issue of a specific country, it's a global issue. Uh, we are living in 21st century, but we still have different region where much of the municipal solid waste is still not collected. So you can see in this diagram, so it's basically telling us that how much municipal solid waste is collected. So that is collected. So either this municipal solid waste which is collected, so you can see the word. Um, so the remaining municipal solid waste is not collected. So either that uncollected waste is either going to unauthorized dumping or is just laying in the street. Um, there are some countries, like for example, if we look at to Australia and New Zealand, so they are performing very well. So 94% is collected, but they still have a potential of 6%. If you look at to Europe and North America, 90% is collected. So still, of course, there is a potential of 10% to improve the collection process and management. Right. If we look at to the Asia, so the figure is barely reaching to 70%. So here we have Central and South Asia, 67%. If you look at to the African countries, North Africa, so it's 74%. So what I want to say that there is a great potential to, first of all, to improve the municipal solid waste management. And when we improve that, then of course we need to look at to um, find some sustainable way of their disposal. So it's not always appropriate to just dump the municipal solid waste in the landfill. So specifically looking to the Oman, it has a population of 4.6 million currently. Uh, in terms of municipal solid waste generation, it produced 1.8 kilogram of municipal solid waste per person per day, which is quite high. I will try to give a comparison with other GCC countries as well. But if we even compare 1.8 with the rest of the world, any other countries, so you will find that this is quite high. Now, what happened with this high municipal solid waste generation? It simply goes to landfill. So they are collecting and they are putting it into the landfill. There are currently 350 landfill. Uh, well, at the moment, they have large amount of land available, so that can be utilized for the dumping of this waste. But in future, of course, this is not a sustainable approach. Uh, and we need to consider their environmental impact as well. So the research is basically, uh, which I have done in Oman. So the research is basically to see what is the current procedure and what emission is coming from that municipal solid waste disposal. And then I have prepared and proposed some framework. This is because that when we look at to the Omani Vision 2040, so it's stressed to reduce the dependencies on oil and gas, but it's also talk about the municipal solid waste management because it is a big issue coming in the future. And Omani Vision, I mean, the leadership has recognized it as an issue. That's why it has taken a place in the Omani Vision 2040. Okay, now let's look at to a brief comparison of the population and the municipal solid waste generation in different GCC region, and you will see how they compare with each other. So here you can see the population, and then this small triangle is basically showing the municipal solid waste generation in kilogram per person per day. Now, Of course, Saudi Arabia has a high population, but still its municipal solid waste generation is 1.8. We look at to Bahrain, it's quite producing a large amount of municipal solid waste, which is 2.7. Now let's look at to Oman. As I mentioned, Oman, so it's producing approximately 1.2 to 1.8 kilogram per person per day. Um, Now, if you compare Oman with other GCC countries, so you might be thinking that yes, it's not a big value in terms of 1.2 to 1.8, but when we compare with the rest of the world, this is still significantly high. So the starting point of my research was to look at to the composition of municipal solid waste. And what I have done, I have collected some sample from different entities which are the main producer of the municipal solid waste. So I consider, first of all, is the residential houses. So the people who basically use different things, food or whatever. So they are one of the main producer of municipal solid waste. So I took a total sample of 100, and in this 100, 90 were from the residential houses. 6 were restaurant, and then 4 were from the shopping market. Of course, we can include other as well. There is waste coming from the hospital as well, but there were some ethical issue. That's why I was not able to collect the sample from the hospital. So this chart is telling us what is the composition of the municipal solid waste in Oman. And I think this is more or less similar across the countries. There might be some differences a little bit, but somehow, at least across the GCC, you will see a similar composition. So we have food items, we have garden waste, we have paper, we have plastic, we have metal, we have rubbers, we have textile items, uh, which clearly tell us that there are some items which can be reused or which can be recycled as well. Like, for example, plastic, we have glass or metal that can be simply recycled. Food item can be used for some other purposes, like, for example, in agriculture activity. So that was the main motivation to proceed with this research. When I come to know that what is the composition, so then in the next stage, uh, I have proposed some framework. So I proposed 3 framework, which I'm going to explain in a bit. Uh, and I try to consider, when I was comparing those frameworks, so I consider the main element of emission. And why I have considered the emission only, because if you look at to the performance of the GCC region and Oman, so their performance in terms of the UN Sustainable Development Goal is quite poor, and they are criticized globally. So this emission is basically affecting a number of UN Sustainable Development Goal, like, for example, climate action. So of course, when there is a high emission from a country, so that contribute to the adversely affect the climate. More emissions mean more carbon dioxide, and then the temperature of the earth is going to increase, and that is going to affect the whole world. So when I was proposing these frameworks, so I have considered 3 main gases in my calculation. The first gas was the carbon dioxide, and the methane, and the nitrous oxide, and this was based on the emission which is coming from those proposed framework. So in terms of when I was calculating emission from the landfill, so I consider the IPCC guideline, how to calculate the emission from the framework. It's provide as an equation, which I have provided here. Well, I will try to explain a little bit this one. I will try to make sure to be in a non-technical manner so that our audience can understand it. But this was the equation which I have used to calculate the emission from the landfill. So of course, you can see the CH4 is basically the methane emission. The municipal solid waste landfill is basically the total amount of municipal solid waste in the landfill in on wet basis. The MCF is the methane correction factor, and based on the guideline, IPCC guideline, I have used a value of 0.6. There is a range of this factor, but I have used an average value uh, because if you want to know the correct value, so then we need to do the experimental procedure, which of course is quite expensive and time consuming. So I have used the existing research, and I try to use, I try to see what values has been used by other people in their research, and then of course I consult the IPCC guideline as well. Uh, the DOC is the fraction of degradable organic carbon in municipal solid waste, and the value used here was 0.2455. The DOCF is the fraction of DOC that can be decomposed, and the value used here was 0.77. Uh, F is the fraction of methane in generated landfill gas. The value used here was 0.5. Or an OX, or is basically the recovered methane. So as we are not recovering methane from the landfill, so the value used here was 0. And the oxidation factor, well, of course, that can be calculated as well, but based on the IPCC guideline, I have used a value of 0. So the framework which I have proposed, so is consider landfilling, and then it's also consider composting. So we can use some of the waste, which is like, for example, coming from the garden or from the food. So we can use that for the agriculture activities. Well, of course, that can improve the agriculture activity as well. But when we do that, there is also emission from that. Um, so there are two emission which is coming from the composting process, which is the CH4 and N2O. So this is how like we have the waste, so that waste can be composed and then it can be used for the agriculture purposes. This is a good idea, but again, still there is emission from this. So this is the equation which I have used. Let me explain quickly this equation. To proceed further. So of course, EM is the emission from the composting. M is the amount of, so here is the M, that is the amount of municipal solid waste that is composted. EF is emission factor. So we have two emission factor when we are going to calculate CH4 or N2O. So for CH4, it is 4, and for N2O, it is 0.3. R is again the recovery factor of methane, and the value used here was 0. Right. We still have a one of the method which is existing in Oman, where, and of course this is also existing in other country as well. Um, uh, we do burn municipal solid waste. It's open burning. We do burn municipal solid waste and related items in Pakistan as well. That also produce emission. There are two types of gases which is coming from the open burning. One is the CO2, and the second one is um, the methane is the CH4. So what I have used a manual which is called Atmospheric Brown Cloud Emission Inventory. Simply, it's called ABCEIM Inventory Manual, um, which is, I think, publicly available. So if somebody is interested, can just try to Google it, and you will be able to find the manual. So this was the equation 3, which has been used to calculate the emission from the open burning. Let me quickly explain different component of this equation. So the EMI is the emission of pollution I in ton per year. Uh, MS MSWOB, so that is the amount of municipal solid waste that is openly burned. Um, well, let me call this sigma. Uh, I hope there will be civil engineers sitting in the audience. So we do use this for stress as well. So that is the fraction of combustible waste. and the value used based on the guideline, the value used in the calculation was 0.94. Well, it seems like a small n, but I just forget what we call it is exactly. But let's assume this is n. So that is the burning oxidation efficiency or fraction. The value used here is 0.59. The EFI is the emission factor of the pollution. So we have two factors in this case for the EFI, per methane and per the carbon dioxide, and both the value has been noted here. You can see it on the slide. So these were the values, and this was the equation which is basically used to calculate the emission from open burning. Okay, now let me explain some in more detail the framework which has been proposed or which has been developed. So the existing framework was noted as a baseline framework. So that was the existing framework, because then we can compare what I have proposed and how it is performing in terms of the emission. So that is the existing approach, which I noted as a baseline framework, or if you can say F0 or F0. So the existing approach to dispose of the municipal solid waste in Oman include landfilling, open burning, and of course there is some amount of municipal solid waste which is uncollected. Then, considering this baseline, I have proposed the next framework. I called it F1. So here you can see that there is some waste which is uncollected. So I said, why we should not collect that waste as well? Because that waste normally goes to unauthorized dumping. So I said, if we improve that and we put it in the proper designated landfill, so what will happen? So this framework basically uh, expand the municipal solid waste collection. Uh, Unauthorized dumping is restricted, and of course, it's also proposed that open burning should be stopped. So we will be having some. So in terms of emission, of course, the landfilling, because more waste will go to the landfilling, so the emission from landfilling will increase, but of course, the emission from unauthorized and open burning will reduce in this case. Okay, so framework 2, which I have proposed, consider two elements. One is the landfilling, and then the next one is composting. So as I mentioned, the composition of municipal solid waste in Oman. So there is a good quantity of waste which can be easily used in the composting process, and the purpose for that was to basically to promote the agriculture activity in Oman. Oman is not an agriculture country. As I mentioned, the economy heavily reliant on oil and gas revenue, so this is a good opportunity for them if they produce, if they improve their agriculture activity. Right, and the third framework is uh, include again three elements. One is the landfilling. So some of the waste go to the landfilling, some of the waste used for the composting process, and then the third option which I have include is to recycle some of the waste which clearly seen in the composition of municipal solid waste in Oman. So these were the three framework developed, and then these framework basically were compared to the baseline framework, and the main factor in terms of their comparison was the emission, as we discussed earlier, that different gases, how it's compared with each other. Okay, so in this table you can see that it's basically telling us that what quantity has been used in different frameworks. So if you look at to the existing or the baseline framework, there is of course open burning, and then there is waste which is going to landfilling, and then there is uncollected waste. The framework, no open burning, no composting, no recycling. So two things: one is the landfilling, and of course there is still some amount of uncollected waste. Right. F2 is somehow different from the previous one. Of course, there is no open burning, but it's introduced the process of composting. And of course, there is some amount which is still uncollected. I think it would be difficult to achieve 100% um, collection of the municipal solid waste. I think it would still, because many advanced countries are still have not achieved that one. So that's why some amount is still uncollected. Now, if you look at to F3, the framework 3, so it's include composting and then recycling, on-site recycling, and then uh, landfilling, and then uncollected waste. Right. So let's go how they perform or how they compare with each other in terms of emission. So let's look at to what baseline is giving us in terms of emission. So this is basically the calculation. I presented in a form of a chart, which could be easily follow and understand. So we have two types of gas. One is the CH4 and then the CO2. Well, of course, there is a translation or to convert that into CO2 equivalent. So if you look at to the total emission, you can see it here. So it's 2.98 million ton per year CO2 equivalent, and there are two component of that, as I mentioned. One is 2.77 million ton of CH4, and the second one is 0.217 of CO2. So you can see clearly CH4 is a main emission from the baseline from the baseline framework. This is the total, as you can see. So you have CO2 and CH4. Right, let's go to the framework one. Again, as I mentioned that the framework one basically improved the collection service and landfilling. So in this case, the open burning is restricted, and also the uncollected amount of waste is reduced. So uh, that is collected and then it's disposed in the authorized landfill station. Okay, so as I was mentioning that it's not possible to collect all the municipal solid waste. So in this case, 60% of the uncollected municipal solid waste is transferred to the landfill, not the total. No open burning, and this is basically the result. And you can see how it's compared with the framework, the baseline framework. So this was the emission from the baseline, and this is the emission from the framework one which has been proposed. So the total emission, let's look at the total emission first of all. So here is the total emission, which is 3.18 million ton per year. That is CO2 equivalent. When we compare with the baseline, so what happened? The emission basically increased by 7%. Now, what is the advantages? The main advantage is when there will be no open burning. So maybe that open burning normally take place in the street or near the houses, so they can result to some mishap as well. So that is restricted, and of course the unauthorized dumping is also restricted. So there is some advantages, but in terms of emission, the emission is basically increasing in this municipal solid in this framework of the municipal solid waste. Right. Now let's look at to the emission from the framework F2. Now you might recall that what I was mentioning in the beginning, that framework 2 basically is include the landfilling, and then it's incorporate the composting as well. And you might see that how much quantity I have considered for the composting purpose. So if you look at to the composition of the municipal solid waste in Oman. So we have food items, we have papers and other items which can be easily used, not easily, but of course that can be used for the composting purpose. So if we look at to those items, it's becoming like 64% of the total municipal solid waste. So that was the idea. So of course, the total material which can be composed may not be possible to achieve. Therefore, what I have considered in this framework, I have considered 50% of that organic waste like the food item, the waste from the garden. So the proposal is that this waste can be used easily for the composting purpose. Now let's look at to the emission. So the total emission in this case is 3.36 million ton per year CO2 equivalent, which is, of course, when you compare with the baseline framework, or when you compare with the first framework, and so you can clearly see that there is an increase. So this is the total from the framework F2. So how much is that increase? It is increase when we compare with the baseline. So the emission basically increase 13%. Now, of course, this emission increase, uh, and when you are doing the composting, you are collecting, you are segregating the waste, so it will definitely increase the cost as well. So that is another element. Um, so apart from increasing in emission, the cost will increase. But what is the advantages? The advantages is it can promote the agriculture activity, and the next advantage, of course, it can reduce the land utilization as well. So in terms of emission, it's not seems to be a good framework, but you can look at to the other benefits. So clearly agriculture and land utilization are the clear advantages of this framework. Okay, so you can see how it's increased by 13%. Okay, now let's look at to the framework, the last framework, which I noted as F3. So it's include landfilling, composting, and then recycling. So the new thing which is coming here is just the recycling. So if you look at the composition of the municipal solid waste in Oman, 16.5% is recyclable waste. So of course, all this 16.5% cannot be recycled. So what I have considered in F3 is to take 50% of this waste to be recycled, which is equal to 331,000 tons per year, which is a good quantity, large quantity. So here you can just recall to see the composition. Now, in terms of recycling, so what can be done in terms of recycling? I have considered two options. Well, of course, there can be another option as well, but my main focus was to focus on two options. One was the waste to energy option. So it might not be the recyclable waste, but we can consider uh, combustible material to be used in a waste to energy plant. So first option was that, which I'm going to explain a little bit more in terms of its performance and its output. And the second option is basically to consider the material recovery facility. Uh, both of them is not existing currently in Oman. We are not using composting as well. So this is some kind of future suggestion. So we don't use composting in Oman. We don't have a waste to energy plant, or we don't have in Oman, we don't have that material recovery facility as well. So the material recovery facility is simply to take the some materials and try to recycle it, or try to use it um, in different production then. Okay, so as I mentioned, two options. So let's look at to the emission from waste to energy option. So the emission in this case is equal to the total waste which we are using um, in the plant, and then the emission factor. So the emission factor, I took it from the existing literature. So it's equal to 80.30 ton per year. And I have used that emission factor. So as I said that this is the waste which I want to recycle. So that waste multiplied by the emission factor. So that give us the total emission in this scenario, which of course is quite high. And then if you look at to the material recovery facilities, it seems that there will be no emission, but there is still emission because you have process to separate the material. So there will be some emission from them. Again, the same equation, total waste multiplied by emission factor. Uh, Again, the emission factor is coming from the existing literature. So you can see the emission factor is quite low when we compare waste to energy option and material recovery facility. So the emission factor is quite low. Therefore, the emission from the material recovery facility is comparatively low when we said waste to energy option. Okay, now let's look at to how these framework compare with each other. So here we have the baseline, the total emission from the baseline. Then we have framework. Just to recall, what is the framework? It's improved the land, it's improved the municipal solid waste collection. So more municipal solid waste is basically transferred to the landfill. Then of course, it's restrict the open burning. And then F2, the framework F2 was incorporate the composting process, and the F3, it's also include landfilling, composting, and then recycling. So you can see how they are comparing with each other. So F1 increase, F2 increase, but when we look at to F3, the emission is somehow reduced. Well, of course, the emission is slightly reduced, but there is still some reduction in the emission. Now, this F3, the emission is reduced because I have considered the material recovery option. If I consider the waste to energy plant, of course, this will increase because the emission from waste to energy plant is quite high. So the total emission in this case in the F3 is 2.95 million ton per year, which is CO2 equivalent. So how much is the difference? It's just 1% difference. So F3 basically produce 1% less emission when you compare with the baseline. So that is just 1% emission. Well, of course, 1% seems to be quite low, but of course we need to look at to the other advantages as well. So just a summary, how these framework compare with each other. So this was the baseline. So I consider that as 0%. There is emission, but for the comparison purpose, this becomes 0%. So F1 increased 7%, F2 increased 13%, and then F3, the last framework, reduced by 1%. Okay, so as I mentioned that this comparison is based on only emission factor. So we can consider if you want to do a robust comparison, so we need to consider other element as well, cost, economic development, or you can say job opportunities as well. So that can be considered as well. Okay, now if I just consider the emission per capita from municipal solid waste in baseline, so you can see how much is the value. But again, if I compare this value with other countries, so it's still very high. Like for example, if we compare with some countries in Europe or in United States, that is quite high. This is just a kind of an overview that how much F1 is produced, how much F2 is produced, and what is a kind of benefit. So as I was mentioning, F2 can reduce the burden on landfill and also can improve the agriculture activity. The framework, the last framework, F3, reduce 1% less emission, but that is only if the material recovery facility is considered. Okay, so this was something, the framework which I have proposed. Now let's look at to the uh, how we can produce, or what are the options are when we consider the waste to energy plant. So how much energy we can produce, and then what will be the implication on what would be the implication on the emission as well. So as you know, energy is very important for our modern life, but we are living in 21st century, but still 13% of the Earth population, they don't have access to modern electricity. Okay, uh, another problem is that the way we are producing our energy currently is not sustainable. So much of the energy is produced from the fossil fuel, and that cannot run in long term, and that's why we need to move towards the um, renewable energy resources. And energy is so important. That's why it has taken a place in the United Nations Sustainable Development Goal as well. Now, what is the goal 7? Goal 7 says we need to ensure the affordable and clean energy for all. Okay, I'm not going to go in detail that what are the target of the goal 7 of UN Sustainable Development Goal, which says affordable and sustainable energy. So of course it's a motivate. First of all, the people need to have access, and then of course it's also emphasize on the renewable energy resources. So I'm not going to go in detail. You might already know this. Now let's look at to the electricity production and consumption in different GCC country. This graph tell us that how much electricity different countries in the GCC are using and what is the CO2 emission per capita. So mainly they are producing their electricity from oil and gas. And if we look at to Oman, 68% of the electricity in Oman is coming from the gas and the remaining is coming from the oil. And here you can see how much is the electricity consumption per capita and how much is the CO2 emission per capita. Right. Now, what this high electricity consumption is telling us is high electricity consumption because it's coming from the non-renewable resources. So because it's coming from the non-renewable energy, that's why their CO2 emission per capita is very high, and that is basically affecting these countries, all the GCC countries, in terms of goal 2 and goal 13. So you can see the score of Oman and other GCC countries in terms of goal 12 and goal 13. So goal 13 is climate action and goal 12 is responsible consumption and production. So it's basically affecting them in those two goals. And of course, we are all the government of different countries, they are committed to achieve the UN Sustainable Development Goal by 2030. So in this scenario, clearly they would not be able to achieve goal 12 and goal 13. Okay, there are many countries which produce electricity from municipal solid waste, like if you look at to Japan, that is leading, then Scandinavia, then Switzerland, United Kingdom, and France. So we have clearly example of around the world that how much municipal solid waste they are using to produce electricity. So like, for example, Japan is using 72% of municipal solid waste to produce electricity. Okay, when we look at to waste to energy technologies, so there are mainly three, but the mass burn facility is commonly used. Okay, now let's look at to the electricity production so that we can be able to compare its emission when we produce it from the municipal from a waste to energy plant. So the current is, consumption per capita in Oman is 15,000 per year.
Tariq, sorry
Yeah,
to interrupt you. We're running short on time.
yes,
Can you
okay.
conclude? Yep.
Yeah, so, no worries. So I will try to speed up. Yes. So okay. So we have a total population. So we, from the total population and from the current consumption, we can calculate how much is the total requirement or how much is the total consumption. As I mentioned that 68 to 70% is produced from oil and gas. So these are the two elements is basically producing the electricity in Oman. So let's look into the emission. So what I have considered, I have considered the emission from the oil, and then I have considered how much emission is coming from the oil and then from the gas as well. So I have done this calculation to calculate the CO2 emission from oil and gas when it is used uh, for the electricity production in Oman. Okay, so we have a total emission in this case, which is 161.781 million ton per year. Okay, so as I was mentioning that more than 50% of the municipal solid waste that can be classified as combustible material, and that can be clearly used in a waste to energy plant. So I have considered a 5,000 ton daily capacity of mass burn waste to energy plant. Uh, there is the literature says that 1 ton can produce 586 kilowatt. So in this case, a 5,000 will produce 2.93 million kilowatt daily. Okay, so based on this, if we do a 5,000 capacity municipal solid waste, so how it will compare in terms of emission? So I have done a calculation considering emission and the reduction in emission. So the calculation tell us that we can reduce 2,455 million kilogram CO2 per year if we go for waste to energy plant. Of course, there are other factors. It's not only the decision can be made on the emission. So there are other factors as well. So we need to consider the cost. So what would be the cost of the initial cost of a 5,000 million, which I have provided here. Then we need to consider the
Yes,
operational cost.
sir, we have ran out of time.
Okay.
We can move to the question and answer session.
Yes. So I think it's just the end. Yeah, it's just the end.
Yes,
So
yes.
just 1 or 2 slides. Yes. Is it okay?
Sure, sure, sure.
Yeah. So again, if we establish this plant, so of course it can provide job opportunity to the people, and of course the electricity production cost is also a factor. So if you compare with other farms, so the electricity cost from the municipal solid waste is comparatively high. Okay, so these are the concluding remark. A number of challenges from the municipal solid waste: land utilization, unauthorized dumping. Uh, Composting can improve the agriculture activity. You have looked at 2 different framework which I have proposed. And of course, I have presented the waste to energy plant as well. In terms of Pakistan, it's generate approximately 49.6 million ton of municipal solid waste in a year, which also increase annually. And 60 to 70% is collected. So we need to think about how we can improve. There is an opportunity to explore municipal solid waste in the context of Pakistan further. Just some key publication. And then thank you very much for your attention. Of course, my presentation was slightly run out of time, so apology for that. And now I'm happy if you have any question. Of course, you can get in touch with me through my email as well. Thank you very much for your attention.
Thank you, Dr. Tariq, for a wonderful presentation. The frameworks that you showed from F0 to F4 are wonderful. I think so they will help us chalk out the future of reducing waste. One surprising fact that appeared was that the food wastage is 38% high. Is it this solid waste or is it the packaging waste? What makes that 38%?
So it's basically, as I was mentioning, that most of the GCC countries, they are basically a high consumer of the earth resources. So in this case, I have only focused on the solid waste. So the food item is basically, I have classified them as a solid waste in this research. So we have collected the sample, then we have weighted, segregated, and then after segregating, we check the weight, and then we dispose it into the nearest dumping point. So the solid waste, precisely.
It's not the packaging. It's not the packaging of the food.
No, no.
It's the food actually. That's a lot of wastage then. One
Correct.
framework that I would like you to comment on is that about reducing what we can do at our homes. Can you give a comment on that? What is the scenario if we start living more smartly and more efficiently? What would be the outlook after that? If you can comment on
So
that.
yeah, I think there is a number of issues which we can do. Like for example, apart from municipal solid waste, well, of course, we have liquid waste as well, which is coming from our washroom, which is coming from our kitchen. So normally when we go to the toilet, so we run the tap and, the water is running out. We are putting soap on our face, so the water is just wasting. So that is a kind of waste. We need to look at to that. We also need to look at to some strategies that might be coming from the government side as well. Um, might be a kind of incentive for the people who basically participate or try to uh, promote. So might be a kind of segregation of the municipal solid waste at their home level. So if we provide them different bins, so maybe one bin will go for like recyclable material, the other bin can go for the waste material, and things like that. Some a bin can also go um, for the garden waste. But I think in this case we need to know that either the people are willing to participate or not. So in this case we have done a survey which I was not having the time to include that in my slide, but we have done the survey, and in Oman the people were quite interested to participate in this kind of activities. So what will happen if we take the scenario of Pakistan? Of course, we have the energy crisis. So I think we might be able to produce energy if we go towards the waste to energy plant. The initial cost is high, but of course, think about in long term. So in long term, we that will give us the electricity. Of course, it will provide job opportunities as well, and we might be leading the region if we don't have other waste to energy plant in our region. So we might become like a technology hub for that as well.
Thank you, Dr. Tariq, for the wonderful talk and for taking out the time from your busy schedule. Now we would like to present a shield to you as a token of appreciation for joining this conference. Kindly accept.
Thank you very much for this. Yesterday I haven't attended the event, but I have watched the recording on the YouTube. So wonderful event and very good organization. And thank you very much for the shield.
Thank you so much, sir, for joining. So this concludes our session one. We had four wonderful speakers, two national, two international speakers, taking out the time to educate us all about energy conservation and efficiency. We had talks from the macro level from Nizami Saab, who gave a talk about circular economy, to the more atomistic level by Dr. Stephen. So we had all ranges of talks. Dr. Tariq shared us the four frameworks of how we can assess our wastage. So it was a wonderful day. The day is not yet over. We have a break from 1 to 2 o'clock, Pakistan Standard Time. We'll be here again at 2 o'clock. Please tune in again. Thank you.